2012 connected particles Leibniz higher level question 4a. We're given this diagram. We're told that two particles A and B, each of mass m, are connected by a light inextensible string passing over a light smooth fixed pulley. Particle A rests on rough inclined plane at alpha to the horizontal, where tan alpha is 5/12. Particle B hangs vertically 1 meter above the ground, and the coefficient of friction between A and the plane is 1/2. So we have mass m, coefficient of friction, tan A. So let's just do a little diagram to get cos A and sin A, the ones that we need. So tan is opposite over adjacent, and you've seen this triangle before, you know that this one is 13. So cos alpha is equal to A over H, and sin alpha is equal to O over H. So the system is released from rest. Find the speed with which B strikes the ground. Well, we have the distance there, so we're looking for V. First of all, let's look what's happening with A, and we'll get our two equations so that we can find acceleration. So here's A. Let's just move on a bit. A. This is A. We have our reactionary force, or string going this way. T. Acceleration is also going that way. We'll call it A. There is friction in this question, so we'll work that out. And we have our just mg coming down. And put my angle in alpha, so coming down this way. Mg cos alpha. Let's write the answer to that. Cos alpha is 12/13, so 12 mg over 13, and parallel to the plane we have mg sin alpha, which is 5 mg over 13. So R is equal to 12 mg over 13. So going down this way equal to going up this way with R. So R is equal to 12 mg over 13. F is equal to mu R. Mu is a half. So F is equal to a half of 12 mg over 13, which is obviously, well, the 2 and the 12 will cancel out and make the 12 6. So F is equal to 6 mg over 13. So we form our equation for A. It's going up in this direction. So we're looking at T minus whatever is going down, which is F, and mg sin alpha. And that's going to be equal to the mass, which is m, and we call acceleration A. So let's put in our values. T minus 6 mg over 13 minus 5 mg over 13 equals ma. So T minus 11 mg over 13 is equal to ma. So if we form our equation for B, what's happening with B? Not much. Let's just put our forces on the diagram. We've got the tension. We've got the acceleration going down. And we have mg. So for B, mg minus T is equal to ma. They're both m, the masses. Okay, bringing this guy across, we're going to get plus T minus 11 mg over 13 equals ma. So that will be 13 mg over 13 minus 11, so 2 mg over 13 is equal to 2 ma. We can cancel out our m's, and we're going to get A to be, well, we need to bring the 2 under and divide, so A is equal to 2 mg over 13 times 2, which is just, sorry, 2g over 13 times 2, which is just, the 2's will cancel, we're left with g over 13 ms to the minus 2. Now we can solve for the speed B hits the ground. So we're asked for the speed. We know the distance is 1. Just double check. Yeah, the distance here is 1 meter. We now have our acceleration. We have g over 13. And we know that the system started from rest, so u is equal to 0. So this is going to give you the equation v squared is equal to u squared plus 2as. So v squared, what we're looking for, v, is equal to 0 plus twice the distance by the acceleration. So v squared is equal to 2g over 13. So v is equal to the square root of that. So just type that into your calculator with g being 9.8, and we will get v is equal to, v is 1.2278, so 1.228 ms to the minus 1. Second part of this question asks, how far will A travel after B strikes the ground? Okay, how far will A travel? So A, what's going on here? Well, the speed it's going to be traveling at when B hits the ground is the same speed that B was, which is 1.288. How far will it travel means that it's going to stop at some point. So V is equal to 0. We're looking for how far. S is equal to S. So we're missing our acceleration here. So let's have a look and we find acceleration. Well, if we go back up to the equation for A, we got this to be the equation for A. Now, what has happened when B hits the ground is that the tension in the string no longer exists. So we have an equation here that we can figure out A, this one here. We just don't need that T because it doesn't exist in the equation anymore. So minus 11 mg over 13 is equal to ma. Minus 11 mg over 13 is equal to ma. So we have A is equal to minus 11g over 13. And this gives us an acceleration of minus 8.2923 minus 8.292. So we have A now. We have u, v. So the equation v squared is equal to u squared plus 2as will help us here. V squared is equal to u squared plus 2as. So 0 is equal to u, 1.288 to be squared. And we have to have different signs here for a and u. So plus twice my acceleration of minus 8.292 times s. So we're going to bring this guy over to the left to make it positive. So we're going to have s is equal to this guy divided by this one. And we're bringing it from the left, and because it's going to be positive 8.292. We can't have a negative distance. So if you do end up with a non-negative sign here, make sure just to be aware of why that can't happen. So if we type this into our calculator, that gives 0.1. Now this is slightly off the official answer because we rounded off with these two here and here. So let's simplify it using non-rounded off just to see what the difference is. We get v squared is equal to this guy squared, so 2g over 13 plus twice, well, it's minus 11g over 13 from here times s. So we're going to get s is equal to 2g over 13 divided by 22g over 13. Thirteens cancel, so do the g's, and we're left with 2 over 22, which is 1 over 11, which is 0.0909, so slightly off with the rounding. So maybe don't round this question off too early.